Okay, so recapping what you should have done with the sub yesterday. When we look here at table 5, what were the values that you put in for 0, 1, 2, 3, 4, and 5? 197, 197, 145, 101, 65, 37, 17. Okay, so because we're testing to see if this is a quadratic, that means that we have to subtract how many times? Twice, because it's the second common difference. So when I find the difference here, when you're finding your common difference, remember that just means that you are doing your y2 minus your y1. Does that make sense? So the common difference from 197 to 145 was what? So it was a negative 52, right? The common difference from 145 to 101 was? Negative 44. Negative 44. 101 to 65? Negative 32. 65 to 37? Negative 28. And 37 to 17. Negative. Okay, so this is our first common difference. Now we're going to find our second common difference. So notice on your second common difference that your negative numbers are getting smaller, right? In order for negative numbers to get smaller, that means you are doing what? You're adding. In order for my negative numbers to get smaller, I'm adding. So what did I get from, how did I go from negative 52 to negative 44? I add 8, right? I went from negative 44 to negative 36 because I added 8, negative 36 to negative 28 because I added 8, and negative 28 to negative 20 because I added 8. So notice how my second difference is the same. Do we see that? So your second difference is the same. Okay. When you're given the equation, you can verify your second difference in a shorthand way. Notice that we have 4 times 2. And what is 4 times 2? So if we did 4 times 2, what do we get? 8. I know you want to square it, but it's a really weird rule that you're just actually multiplying it by 2. When you did your table 4, what should you have gotten? Negative 6. Did you guys get negative 6 yesterday? Yes. When you did table 3, what should you have gotten? Plus 4, a positive 4, right? And is that what you got? Yes. So we can come to the conclusion here that the relationship between our second difference and our equation, it involves our A, right? Our equation is going to always be, so second difference equals A times 2. Does that make sense? So for a quadratic, your second difference is going to be A times 2. So whatever your A is, you're going to multiply by 2. Remember, A is just your leading coefficient. Pandora is really trying to make me be a different person, and I don't like her right now. Okay. All right. How do we feel about quadratic? Questions, comments, concerns about quadratic? So if I gave you a table, because this is what you're going to be doing tomorrow, if I gave you a table, could you identify it as a quadratic? No. Okay. Why are you saying no? Did you understand what we just did here? So what we did here was we subtracted. So we have to find a second level of subtraction. So when I subtracted the first time, the numbers were different, but there was a pattern in the second subtraction. That pattern lets me know that this table represents a quadratic function. And that's it. Yes.
Why are we circling the number and then?
Oh, I was circling it to show you that you can figure out what if you did it right, or if your difference makes sense by multiplying. So if I had 4 times 2, what does that make? 8. And that was my second difference, right? When you did this whole table yesterday and you had negative 3 times 2, you got negative 6. How come it's what? Because it's your y2 minus your y1. So it's 145 minus 197.
Oh, okay.
So it's your y2 minus y1. So it's this, the y that follows minus the first y.
Okay, so, and then after you do that.
Then
it'll
it's
be
negative 44 minus negative
101.
50.
No, what?
Like, oh, you're saying continuing here?
Yeah.
Yes. So it would be 145 minus 197, 101 minus 145, 65 minus 101, 37 minus 65, 17 minus 37.
And then you do the same thing for the other side.
Exactly.
Okay, that's why I confused.
So your 8 is your common difference. So if I gave you a table without the equation, you'd have to analyze the table just like we did to determine, is it a quadratic representation? Before creating a scatter plot, before creating a regression, can you tell me, is it going to be a quadratic? If it's quadratic, that means the second difference is the same.
But it's always the second.
It's always the second. If it's the first difference, that makes it a linear.
Okay. How do we get the numbers for the plotting on the Y?
We plugged in our x values into the equation.
Oh, yeah.
All right, any other questions about the quadratic table? Okay, no, we're good. All right,